Everybody, welcome back. In this video, we're going to be talking about the question, do heat pumps work in Wisconsin? Let me tell you a little bit about my house first, and then I'll answer this question for you. This is meant to be an informational, instructional video to give you questions to ask, things to ponder as you consult with your HVAC contractor, or maybe you're going to do this whole thing yourself like I did. I live in a 2016 square foot house on the east side of Madison, and we heat and cool our house with a cold climate heat pump. We do not have a gas line running to the house anymore. We have some electric resistance coils that are inside the heat pump that act as a backup heat source, which frankly we've never even turned on in the last 2 years that we've had the cold climate heat pump. So how do you know if your house or your condo or apartment or whatever can be heated and cooled with a heat pump? Well, to make a long story short, this is just a big math problem. That's all that this is. We don't need to worry about, hunches and experience. It's just a big math problem, folks. Okay. And the question is, what is the load of the house? Let me say that in some different language. What's the need of the house? What's the demand of the house? How many heating units does the house need? Once I know what that number is, then I go shopping for equipment that will meet that need. So let's just do it with a furnace, for example, because that's a really easy one. A furnace has an output. It has a BTU output. BTU is a British thermal unit, and the furnace will say, okay, if I have a 40,000 BTU furnace, that means that this furnace, this piece of metal that has a gas line running to it, can put out 40,000 heat units per hour. And that output of that furnace is not dependent upon the temperature outside. It could be 40 degrees outside or negative 40, and that furnace is still going to put out 40,000 BTUs of heat per hour. Okay? Period. Works like clockwork. Doesn't care what the temperature is inside, doesn't care what the temperature is outside. Doesn't matter. Heat pumps are different. Heat pumps care about the temperature outside because heat pumps are not creating heat. Heat pumps are moving heat. In the wintertime in Wisconsin, heat pumps take heat out of the air outside and pump it into the house. As it gets colder outside, there's less heat in the air that it can take and move to the inside of the house. As a result, heat pumps lose some of their output, some of their capacity. They can move less heat as it gets colder. So, my heat pump is a 24,000 BTU heat pump, also called a 2-ton, okay? It can put out 24,000 BTUs of heat down to 5 degrees Fahrenheit. It's either 5 or negative 5. After that, the output starts to decrease, so that at negative 22 degrees Fahrenheit, my heat pump can only put out 78% of 24,000 BTUs, or 78% of its fully rated capacity. So this matters because as it gets colder, heat pumps can put out less heat. So I need to make sure when it gets cold at what's called design conditions for, I think, Madison, it's like negative 12. At negative 12, what is the capacity of my equipment and what's the need of my house? And those numbers need to match up, or the capacity needs to be a little bit higher than what the need of the house is. So you might be saying, well, geez, what happens if the house needs more than the heat pump can provide when it gets really cold? Well, you have a couple options. Number one, you can have a dual fuel system. Or number two, you can have what I have, which is electric resistance coil backup. It's like having a little toaster element in your heat pump. And basically, you run a separate electricity line to your heat pump, and these coils will glow red hot, and then the fan in your heat pump will blow over them to provide extra heat to the house when it gets really cold. The heat pump will still run. The refrigeration cycle will still happen when it gets really cold. it's just limited in how much heat it can produce. So the coils, the electric resistance coils, they supplement during those cold temperatures. Now, some of you might say, well, geez, Stephen, electric resistance heat is very expensive. It is. I agree. But keep in mind that, for maybe 90 or 100 hours out of the whole year, you actually would need the electric resistance to kick in to supplement. Like I said, we've had our heat pump for the last 2 years, and we have not used our electric resistance at all. Partly because I've been afraid of, geez, how high are these bills going to go? But the heat pump has been able to carry the load of the house. And if it gets really cold, we might put on a coat or a hat or use an extra blanket. But most of the time when it gets really cold, it's just touching those cold temperatures for like 30 minutes or an hour or 6 hours or 2 hours or in the middle of the night when you're sleeping and you're under the covers anyways. It's not like negative 50 for 17 weeks. That's not happening. Okay, so when you choose to get a cold climate heat pump in Wisconsin, you can do that. And your options are to have electric resistance backup, which are those little coils. And those coils are cheap. It's like an extra $250 or something. It's like next to nothing. Or you can get a whole extra furnace backup. Now, the thing with getting a whole extra furnace backup is when you have a dual fuel system, I think this happens, the heat pump will literally shut off at a certain temperature and the furnace will just take over. So if the load of your house, like my house is about, I think it's 19.8 thousand BTUs, I need to have a furnace that can put out the full need of the house. So I need to find a 20,000 BTU furnace. I don't even think that they make those. So you need to upgrade to like a 30,000 or a 40,000 BTU furnace to carry the load for the small period of time when the heat pump can't. Keep in mind, you're also paying for the monthly service fee just to have the gas, which in my case was $25 or $30 a month. I was paying more in service fees for my gas than it was for therms actually used. But you can go with the dual fuel system or have the electric resistance backup. Some of you might have a fireplace or a pellet stove or a wood burning stove or something that can also act as a backup when it gets really cold. But keep in mind, the amount of hours that we're talking about when the heat pump won't keep up is very small. It's like less than 90 hours per year, okay? And all these hours are not typically happening continuously. They're happening sporadically, intermittently, okay? Anyway, that's all I want to say for this video. I hope that helps a little bit. Keep asking questions, and best of luck with your heat pump endeavors.